Okay, review topic number 9, isotopes and average atomic mass. Okay, so isotopes are atoms of the same element that have a different number of neutrons. So they have the same number of protons, but a different number of neutrons. Same atomic number, but different mass number. So you can see lithium, 3 protons. Lithium, 3 protons. Lithium, 3 protons. Atomic number 3, atomic number 3, atomic number 3. Same atomic number, same atomic number, same atomic number. But look at these mass numbers. They're different. So what's different? The number of neutrons. They have the same number of protons, but a different number of neutrons. Same atomic number, different mass number. Same element, different mass number. Same element, different number of neutrons. Okay? Whole bunch of ways to say the same thing. All right, so average atomic mass is the weighted average of all the naturally occurring isotopes of an element. In order to calculate the average atomic mass, you need the percent abundance and you need the atomic mass for each isotope. To change a percent into a decimal, you divide it by 100. And then you're going to multiply it by the atomic mass. And then you see all these plus signs. You're going to add them up. So let's work through an example. Okay. So let me get this up so you can see what I'm doing. Okay. Let me move this over so I can actually see the numbers. There we go. All right. So my first percent, okay, is 90.48. Okay. So I have to convert that to a decimal. So I divide it by 100. Now I know shorthand, that means I just move the decimal over 2 places. But if you think you're going to do it wrong, use the calculator, divide by 100. So that's going to give me 0.9048. Okay, my next percent, is very small, 0.2710. Divide that by 100. And I will get 0.002710. Okay, and then my last percent, 9.253, divide that by 100, and I get 0.09253. Now I need to multiply these decimals by the correct atomic mass. So this one went with 19.9924. This one went with 20.9938, and this one went with 21.9914. Okay, so let's pull up the calculator. All right, when I pull up the calculator, I'm going to go to scientific so that I can use parentheses. Okay, so I'm going to do parentheses 0.9048 times 19.9924 and parentheses plus, because I'm going to need to add these numbers up at the end. If you are not comfortable setting it up like this, you're going to write this number down right here. So I would say equals 18.08 9125352. I'm going to just write that down. But I'm going to go on to the next step. Here, another parentheses, 0.002710 times 20.9938 and parentheses. And I am just going to write this down just so we can check it at the end so you are convinced that I did it correctly. 893198 plus parentheses 0.09253 times 21.9914 and parentheses. Write that one down, 2.034864242. Okay, on here I'm going to press equals, okay? And this is what I believe my answer is, 20 20.180880096. U is atomic mass units. But just so you're convinced that I did it right, I'm going to write down, I'm going to add these numbers. So let's clear this. I wrote it down here. Let's clear it and let's add up 18 point. So if you are not comfortable with using a calculator like I did, you could write it down in between 1, 2, 3, 5, 2 plus 0 0.05, 6, 8, 9, 3, 1, 9, 8 plus 2.034864242 equals. You see that? I got the same thing. So just using the parentheses kind of saved me a step. So here's my answer, but I need to check significant figures. So let's go look here. I need to know what the lowest number of significant figures are. Well, all the percents have 4. So that means my answer needs 4. 1, 2, 3, 4. So 20.18U. Now, this was what element? Neon. So what I tell students to do is go to the periodic table, find neon, and look at its atomic mass, okay, on the periodic table. So right here, okay, it's a little hard to see. So it is 20.180 on the periodic table. Well, my answer and that answer are ridiculously close, so I'm good. So that's how I know I did it correctly. And that's it. That's how you do average atomic mass for isotopes.